Welcome students, this is Pankaj Singh, askIITian faculty working with askIITians since last 3 years. Now we are going to start the chapter Biomolecules. As the name suggests, it involves the study of those molecules or those chemical compounds which involve in biological system. We'll study about carbohydrates, protein, vitamin, enzymes and many more, but we'll focus mainly on carbohydrate, amino acids, that is proteins, and nucleic acids. So let's start with carbohydrates. Carbohydrates are compounds of carbon and hydrogen, and they are basically the source of energy. Glucose, sucrose, fructose, these all are carbohydrates and these provide energy. So the basic function of carbohydrates is to provide energy. Let's start their study. Carbohydrates. Carbohydrates are actually those biomolecules which provide us energy. Whatever we eat is broken down into glucose, and from that glucose we get energy which is used by our body for biological processes. So carbohydrates are chemically compounds of carbon, hydrogen and oxygen, and they are sometimes also known as sugars or saccharides, and their general formula can be represented by this formula C6H2O whole Y. So let's write, let's say if we have 6 carbon atoms, in that case the formula will become 6C6 then H2O whole 6. If we simplify this, we get C6H12O6, which is actually the formula of glucose and also fructose. So this is the general formula of carbohydrates. Now next is classification of carbohydrates. Carbohydrates are classified on the basis of their structure as monosaccharides, oligosaccharides and polysaccharides. Monosaccharides actually the simplest form of carbohydrates, and they cannot be broken down further into more simpler form, and the most famous monosaccharides are glucose, fructose, galactose. Next is oligosaccharides. Oligosaccharides actually contain 2 to 10 monosaccharide units joined together. If they have 2 monosaccharides units joined together, they will be known as disaccharides. If they have 3 monosaccharides units, they would be known as trisaccharides. If they have 4 monosaccharides units, they will be known as tetrasaccharides. But the most important oligosaccharides are actually disaccharides, and maltose, sucrose and lactose are the example of disaccharides. These all are formed by combination of 2 monosaccharides unit. We will discuss their structure in detail in coming slides. And these two, monosaccharides and oligosaccharides, mainly disaccharide. Monosaccharides and disaccharides are known as sugars. They are also known as sugars because they have sweet taste as well as they are soluble in water. And we know that sucrose is actually the general sugar which we use in our food. It is cane sugar. Glucose is a sugar, fructose is fruit sugar, maltose is malt sugar, lactose is milk sugar, and sucrose is cane sugar which we use. Polysaccharides are known as non-sugar carbohydrates, non-sugar, because they are not sweet in taste as well as they do not dissolve in water. They do not show the properties which generally monosaccharides and disaccharides and oligosaccharides show, and these include starch, cellulose and glycogen. Classification of sugars, that means monosaccharides and disaccharides, these can be classified as reducing sugars and non-reducing sugar. Actually, a carbohydrate contains 2 functional groups in its structure. First is this carbonyl group and next is this alcoholic group. These 2 groups are present in a typical carbohydrates. So those sugars, that means monosaccharides and disaccharides, in which this carbonyl group is free, are known as reducing sugars because those can reduce Fehling solutions and Tollens reagent, because these are the tolerance reagent test and Fehling solution test is used for detection of aldehyde and ketones, and those who have free aldehydic and ketonic groups in them will obviously reduce tolerance reagent and Fehling solution, so those will be known as reducing sugars. So those sugars which have free functional group, that means this group, and those can reduce tolerance reagent test, and those can reduce tolerance reagent and Fehling solution are known as reducing sugar, and actually all the monosaccharides are reducing sugars. On the other hand, there are some sugars in which this carbonyl group is actually not in free form, and they have bounded functional group, that's why they cannot reduce tolerance reagent and Fehling solution, and that is why those are called non-reducing sugars. Now, classification of monosaccharides. As I told you that all the sugars, especially monosaccharides, have a carbonyl group, and this carbonyl group may be aldehydic and ketonic. If they have aldehydic, they are known as aldoses. If they have ketonic group, they are known as ketoses. So this is the classification. If there is a carbohydrate with 3 carbon atoms, it would be known as triose, and it has 3 carbon atoms plus an aldehyde group, so it is aldotriose. If it has 3 carbon atoms and a ketonic group, it would be known as ketotriose. For aldehyde, aldotriose. For ketonic group, ketotriose. Similar is the case with 4 carbon atoms. If a carbohydrate with 4 carbon atoms has aldehydic group, it is aldotetrose. If it has ketonic group, it would be ketotetrose. Similarly, if a carbohydrate has 6 carbon atoms and aldehydic group, it would be known as aldohexose, and if it has ketonic group, it would be known as ketohexose. And the most famous example of aldohexose is glucose, while ketohexose is fructose. The formula of both is C6H12O6. The difference is in functional group. We'll study their structures in more details in coming videos, but as for here, we know that glucose is aldohexose and fructose is glucose is aldohexose and fructose is ketohexose. Now let's have a look at some of the structures of these monosaccharides. Okay, so the first simplest monosaccharide is glyceraldehyde, and the formula of glyceraldehyde is actually CH2OH. Now this can be written in two forms, this form as well as we can write it in this form also, like CHOOH on this side, H on this side, and CH2OH on this side. This is known as D form, this is known as L form. So this is actually D-glyceraldehyde and this is L-glyceraldehyde. So if we start with D-glyceraldehyde, this is the simplest form of monosaccharides or carbohydrates. This is D-glyceraldehyde, and the plus sign represents that it is dextrorotatory or levorotatory. For plus it is dextrorotatory, for minus it is levorotatory. Okay, so this is D-glyceraldehyde. It is actually a it is aldotriosed. Okay, next is, if we increase this carbon length by 1 carbon more, we will add 1 carbon here. So we get D-erythrose or D-threose. If the new OH group is on this side, it is D-erythrose, and if it is on left side, it is D-threose. This is threose, this is erythrose, and these two are actually aldotetrose, 4 carbon atoms, aldehyde group. Now this D-erythrose, if one more carbon atom is introduced with one OH group also, so it will form D-ribose if the new OH group is on right hand side, and if it is on left hand side, it would be D-arabinose. Similarly, threose can be increased to give D-xylose, in which the new OH is on this side, right side, and if it is on left side, it would be D-lysose. So erythrose give rise to ribose and arabinose, while from threose we get xylose and lysose, and these are aldopentose because these have 5 carbon atoms. These are aldopentose. Next is if we take ribose and we further add one more group, we'll get allose if OH is again on right hand side, and if it is on left hand side we'll get altrose. Similarly, ribinose gives rise to glucose and mannose, while xylose gives rise to glucose and idose, and from lysose we get galactose and talose. Now from here you'll get an interesting thing, that if we talk about these two, actually these two, erythrose and threose, have almost similar formula, but the difference is that they differ in one carbon atom. On this carbon the OH is on right hand side, while on the same carbon in this compound it is on left hand side. So such compounds, such carbohydrates which differ from one another only by one carbon atom are known as apimers. And this carbon atom is apimeric carbon atoms, and these two compounds are apimers. Similarly you can see glucose and galactose. This glucose and galactose differ from one another only by position of OH and H group at this carbon atom. So these two are also apimers. So apimers are those monosaccharides which differ from one another only by orientation of the group at only one carbon atom. So this was the structures of various monosaccharides. Next is Kilani-Fischer synthesis. We have just studied that in this previous slide, we just studied that what we get if we increase the carbon by 1. We added one more group to aldotriose and we moved to aldotetrose. So now the question comes, what is the method to increase this carbon chain? And the answer is Kilani-Fischer synthesis. In this method is used for lengthening the carbon chain of aldose. And what is done in this, you can see from here that this was a 1, 2, 3, 4, a tetrose. This was an aldotetrose. First of all, we react with NaCN or HCN in water, and this group gets this was actually OH group. If I write it in more broad way, so it was like this: OH, then OH, H, here was CH2OH, and this was actually this group. We add HCN or NaCN in the presence of water, and this opens up actually. We get this portion, similar OH here, then OH here, H here. Now difference is in this position. This could be like this, or this may be like CN here, CN and on this carbon OH, OH. And when these two are further reacted with water, hydrogen gas, which is actually acidic in the presence of palladium, BaSO4, this group gets converted into aldehyde. This CN gets converted into aldehyde. So we get this compound. So overall, what we see that we started from 1, 2, 3, 4 carbon atom, and we have now 1, 2, 3, 4, 5 carbon atoms. So this is Kilani-Fischer synthesis, which is used for increasing the chain, and we have just studied that what we get when we increase the carbon chain of any compound. If we start with glyceraldehyde, we get erythrose and threose. Similarly, when we proceed with threose, erythrose, we get ribose and arabinose. So this was all about Killian-Fisher synthesis. Next is rough degradation. This is actually opposite to the Killian-Fisher synthesis in that we increases the carbon chain, but in this we decrease the carbon chain. In this involves oxidation of the aldose into aldonic acid. We actually oxidize that aldehydic functional group into carboxylic acid functional group to convert aldose into aldonic acid using bromine water, and then oxidative decarboxylation of that aldonic acid which was formed results in a decrease of the carbon chain like this. This is actually ribose. We just first of all oxidize this functional group aldehyde into carboxylic acid, and we got from ribose to we get ribonic acid, and then we do oxidative decarboxylation. Decarboxylation basically refers to the removal of carbon CO2 molecule, and we are left with erythrose. So this is a way to step down to decrease the length of carbon chain. Next is salt example. Which of the following is an aldopentose? So we know ribose is an aldopentose. It has 5 carbon atoms and it is formed by if we start, we had CH2, we had yes, it was CHO, then OH, then CS2OH, then we moved to CHO, OH, CH2OH. This is actually, this was glyceraldehyde. Then from this we used Killian-Fisher synthesis to form erythrose, and from erythrose we moved to ribose, and it was CHO, then OH, another OH, one more OH, then CH2OH. So this is an aldopentose. So ribose is the correct option here. Next is, to become a carbohydrate, a compound must contain at least 3 carbon atoms. There must be at least 3 carbon atoms, because we know the smallest carbohydrate is glyceraldehyde with 3 carbon atoms. So correct option is B here. It must have at least 3 carbon atoms. Next is the functional group present in typical carbohydrate. We know that carbohydrates have carbonyl carbon. It has carbonyl functional group as well as alcoholic functional group. So these two are the essential functional groups required for a compound to be carbohydrate. So the correct option here is C. So students, now we are aware of carbohydrates. We know what are carbohydrates, what is their function, and what are the different type of carbohydrates: monosaccharides, disaccharides, trisaccharide, polysaccharides, and so on. So in our next video we will focus on a monosaccharide, glucose. We will study its properties and preparation. Keep watching. Thank you.